class. So this week we're covering chapter 6, experimental designs. Experimental design is where the researcher manipulates the independent variable, usually known as variable X, and observes the changes in the dependent variable known as variable Y. While the independent variable is also known as the causal variable, and the dependent variable as the outcome variable. The independent variable is the variable that explains or causes a change in the dependent variable. It is the intervention in experimental designs. Dependent variable is the variable being explained or caused in that the intervention is targeting. So manipulation is accompanied by random assigning participants to the experimental or control groups. With random assignment, it ensures that the people have an equal chance of being in either group. The groups are the same at the outset of the experiment so that any change can be attributed to the intervention. So basically the goal of randomly assigning participants to groups is to make sure that all participants have an equal chance to being in either group, the control group or the experimental group. So experimental designs are useful for evaluating the effectiveness of social work interventions. It's useful for advancing a science of social work, and it's also useful for informing practice because they establish causality, which is the relationship between cause and effect. So the experimental designs basically establish that the independent variable has really caused a change in the dependent variable. There are three conditions to establish causality. One is cause precedes outcome. So the cause or intervention must precede the outcome in time. If the outcome precedes the intervention, it could be attributed to some other variable not included in the study. These are called extraneous variables or confounding variables. The independent and dependent variable must be empirically correlated. This requires collecting and comparing data on the outcome before the intervention, which is pre-test, and after the intervention at post-test. The relationship between the independent variable and the dependent variable cannot be attributed to any other variable that explains away the relationship between two variables. So basically, in order for you to say that there's a cause and effect, or that the independent variable really caused the change in the dependent variable, these three things must be met. Okay, so the cause has to come before the outcome, so no other extraneous factors involved. There must be an empirical correlation between pre-test and post-test, and the change cannot be attributed to any other variables. In a pre-experimental design, the researcher or someone else manipulates the independent variable and then observes resultant changes in the dependent variable. The researcher does not randomly assign people to an experimental group, and there is no control group. There are three types. A pretest is a measurement of the dependent variable before the manipulation of the independent variable, while a post-test is a measurement of the dependent variable after manipulation of the independent variable. Pre-experimental designs are well suited for exploratory research because they allow the researchers to examine the relationship between the variables. It allows researchers to infer but not establish causality because the condition of randomization of participants is not met. It can help gain insight about the phenomenon under investigation and lay the groundwork for an explanatory study. The research questions examine association between variables in established temporal order. Proposed questions that examine the association between the independent variable and the dependent variable. Research questions allow the researchers to establish temporal order as they control the timing of intervention and observation. The hypothesis focuses on an association between the independent and dependent variable. A non-directional hypothesis that states that there is no relationship between intervention and outcome is not appropriate in this case. In some cases, one will not have a hypothesis, such as when using a pre-experimental design for exploratory research purposes. So you don't always have to have a hypothesis when you're doing a research study. Purposeful sampling is a strategy used to select study participants based on the researcher's knowledge of the population. Convenient sampling entails selecting participants who the researcher has ready access to. So with purposeful sampling, the researchers select their participants based on what they know about the participants. So they fit the purpose of the study. Convenience sampling is selecting participants that the researchers have access to. Data are analyzed using descriptive statistics such as frequencies and inferential statistics such as z-test or t-test. The type of z-test or t-test used will depend on the study design and the level of measurement of the dependent variable. So a z-test is appropriate when the independent variable as well as the dependent variable are nominal variables. It assesses the differences between the proportion for the groups. It's also preferable to use a z-test if the sample size is greater than 30. As far as the t-test, this is appropriate when the independent variable is nominal and the dependent variable's interval or ratio. It assesses the differences between the means for the groups, and it's preferable to use the t-test if the sample size is less than 30. In a one-shot case study, the researchers observed the effects on the dependent variable for only one group. It measures it only after the intervention has been implemented, so only at post-test. This is the weakest pre-experimental design. It does not allow study of the association between variables because of no variation in the independent variable. Persons are not randomly assigned to the group, extraneous variables are not controlled for, and it leads to weak internal validity. The standard notation for this design is the X is the intervention and O for the measures of observation. As there are no pretest data, the post-test scores is compared with the cutoff score for the measure used to assess the outcome variable. So a cutoff score indicates if a score puts someone in a certain category. Data can be analyzed using the z-test or a one-sample t-test, as dependent variable was only assessed once and on an interval level. Internal validity is the researcher's ability to conclude that the change in the dependent variable is definitely attributed to the manipulation of the independent variable. External is the researcher's ability to generalize the study's results beyond the persons included in the study. There are several threats to internal validity. The first one is history. So history is a threat if some event occurred at the same time that the participants received the intervention, which resulted in the outcome. The threat of maturation occurs if there is a long time between receiving the intervention and assessing the outcome variable, so maturation might account for the score. Selection bias happens when there's no comparison group and we cannot know if the outcome was likely for reasons other than that of the intervention. Mortality is when there's a lapse in time between intervention and assessment, and participants may drop out of the group prior to the assessment. This is also known as attrition. So with threats to external validity for this design, it is affected by the interaction of selection and the independent variable. So a characteristic of the participant may have resulted in them responding differently to the intervention, so the results may not be able to be generalized beyond the participants who received the intervention. The one-group pre-test post-test design allows examination of the association between variables because of assessment before and after the intervention is implemented. Time order is established by manipulating the independent variable and assessing the dependent variable prior to the implementation of the intervention, and then again after the intervention has been implemented. So the standard notation for this is you have O1, X, and then O2. O1 is the pretest, X is the intervention, and then O2 is the post-test. Persons are not randomly assigned to the group, therefore extraneous variables are not controlled. So for data analysis, this can be through a paired z-test or dependent samples t-test. Dependent variable was assessed twice and is measured on an interval level. So those have to be the conditions for you to be able to do the z-test or the t-test. Threats to internal validity. So history is a threat in this design. So a change between pre-test and post-test can be attributed to some event that occurred the same time that the intervention was received. If there is a long time between pre-test and post-test, maturation might also account for the differences. Testing is also a threat here. So people do well on post-test because of taking the pre-test. Instrumentation is also a threat with this design. So a change in the measure used to assess the variable. So for example, if you use one pretest and you change it at post-test, then you'll have a threat of instrumentation. Statistical regression to the mean is another threat to internal validity. So if participants had extreme high or extreme low pretest scores, their average post-test scores tend to be better. As we can see for this design, we have a couple more threats to think about. When it comes to external validity, the interaction of testing and the independent variable. So as a result of pre-testing, participants may become sensitized to the treatment, and then the results may not be generalizable. There's also the threat of interaction of selection and the independent variable. So ways to improve this design. Participants can be randomly assigned to the various times the dependent variable is being measured. Pretest data can be collected twice. So if pretest post-test difference is greater than the difference between the two pretests, then one can conclude that the intervention accounts for the findings. And the time series design may also enhance the ability for you to infer causality. So then we have the post-test only design with non-equivalent groups. This is also known as a static group comparison design. It observes changes in outcome variables for one group, but measures after the intervention for both experimental and comparison group. It compares the means of two groups. It determines the association between the variables by comparing the means of the two groups and finding a difference. With this design, only a post-test is given. So if you look at the standard notation, we have an X, which is the intervention, and then we have an O1, which is the observation. And then at the bottom, there's no intervention, but there's also an O1, which is basically your post-test. So basically, if you look at the design, a post-test is given to both groups. One group gets the intervention and then is given the post-test. The other group doesn't get the intervention, but also gets the post-test as well. And then we compare the post-test for both groups. So data can be analyzed using the two sample z-test or independent samples t-test. The dependent variable is assessed only once using two different samples and measured on an interval level. The threats to internal validity for this design is selection bias, so comparing groups that are non-equivalent at the outset without pretest, one cannot determine if the groups were the same or different prior to receiving the intervention. So without a pretest, we cannot tell whether the groups were the same or different at the beginning before getting the intervention, and so we have a selection bias. So differences in the groups or results may be due to the differential dropout of participants across the groups and interaction of selection and maturation. So groups may differ because of developmental changes in the individuals within the groups. So we mentioned that the pre-experimental designs are the weakest designs because we cannot establish causality, and they also lack internal validity. However, it's still useful to do pre-experimental designs. They're useful for pilot studies. Pre-experimental designs are also useful when one does not have adequate resources to conduct the experimental design study. Results should be interpreted with caution and cannot be generalized to other samples or settings. So it's still useful to do them. We just have to remember that the results cannot be generalized. And it's also a great way to do a study when you have no access to a control group. So the differences between the pre-experimental and experimental designs is that in an experimental design, participants are randomly assigned to the experimental group and the control group. And the experimental group is basically the group who's getting the intervention. Control group is the group who's not getting an intervention. So with this design, pre-test and post-test data is collected in both groups. It allows researchers to determine if there's causality, and there's also 4 different types: pre-test, post-test control group, post-test only control group, the Solomon 4, and the alternative treatment with pre-test. Experimental designs are used for evaluation research, particularly to determine the effectiveness of an intervention or a policy. So the research questions focus on causality, there's manipulation of the variable, and personal attributes are really not the focus for experimental designs. So propose questions that will get at determining causality. For example, can mindfulness reduce post-traumatic symptoms of veterans? Questions that focus on determining causality require that the independent variable be manipulated, and questions that examine how a person's attribute contributes to an outcome are not to be used with experimental designs. For example, a question like, are boys more likely to engage in violent behaviors than girls? The hypothesis should predict the direction of the relationship between the independent and the dependent variable. So non-directional hypotheses are not appropriate for experimental designs as they are not congruent with the second condition to establish causality. For the data analysis strategy, we use descriptive statistics such as frequencies. We use inferential statistics, so you can use the two samples z-test or the independent samples t-test. Analysis of variance or ANOVA, or the analysis of covariance, is used to statistically control for extraneous variables. So in a pre-test, post-test control group design, individuals are randomly assigned to experimental or control group. Pre-test and post-test scores are compared. Difference in score for the experimental group can be attributed to the intervention. There should be no change in score for the control group as they did not receive the intervention. So with the pre-test, post-test control group design, there's 2 groups, one that gets the intervention and one that doesn't. And really you're hoping that only the group with intervention would have any changes. Random assignment rules out the explanation that the outcome was due to some personal characteristic of the participants in either group. So random assignment takes away any other explanation, takes away any other reasons for changes in the participants who have the intervention. The standard notation for this design, as you can see, is there's an R in this one, and the R basically just stands for random assignment. There's the O1 for observation, which is the pre-test. The intervention is the X, and then O2 is the post-test. So there's that for group 1, and then for group 2, as you can see, there's the R, the O1 pre-test, there's no intervention, and then the post-test. This design establishes causality by meeting all 3 conditions. There's 2 comparison groups to establish association, the variation in independent variable before assessment of any changes in the dependent variable to establish time order, and then random assignment to groups to establish non-spuriousness. Threats to internal validity for this design. This one is one of the strongest designs to establish causality. It is not affected by many of the threats to internal validity, but it can be affected by testing because we do have the pre-test and post-test. So testing is a threat for this design. So in the post-test only control group design, individuals are randomly assigned to the experimental and the control group. Such designs may be used if one thinks that pre-testing may affect post-test or if pre-testing cannot be done. Without the pretest, one cannot conclude but can only infer that the difference in post-test scores were due to the intervention. Data can be analyzed using the 2 samples z-test or the independent samples t-test. For this design, the dependent variable was assessed once and measured on an interval level, and the independent variable measured on a nominal level. Ethics and diversity issues associated with experimental designs. Competency 1 emphasizes ethical decision making at all stages of the research process, especially in the case of human subjects. Putting participants in a group where they will not receive any treatment is considered unethical. So, an alternative to not giving treatment is that the control group receives standard treatment normally provided at the agency. So, for example, if you are doing a study and you have two groups, one that's getting the intervention, one's the control group, you'll basically have the control group be the people who are on a wait list or the people basically who are getting treatment but not the actual intervention. The principle of respect for persons asserts that individuals have a right to decide about participating in a research. So participants can choose whether they want to be in a research or not. So sometimes participants may feel undue pressure to participate in a study, and there's different reasons for that. It can be their own social status or the researcher status. For example, if I'm doing a study and I ask you guys to participate, you may feel undue pressure to participate because you may feel like she's my professor. Like if I don't do the study, she might look at me differently or she might, not give me a good grade. So you may feel pressured even though those things should not be related at all. Another reason for people feeling undue pressure can be immigrants who may have the fear of being deported if they do not participate. Another reason is if a researcher has a dual role relationship with the participant. So maybe if the researcher is also the participant's therapist, this also places undue pressure. So a safeguard for this is to have someone else obtain informed consent from the client to participate. So we have to be very careful that we're following these ethical guidelines when doing research. So when it comes to diversity issues, informed consent may have to be modified depending on the participant's cultural background. So for example, in some cultures, family decision making, not individual, is a norm. Competency 2 underscores the importance of preventing oppression, abuse of power, marginalization, and alienation from occurring, as well as we conduct experimental research. So this is done through getting informed consent and keeping data confidential. While translating consent forms, a researcher has to decide whether to do a word-for-word translation or use colloquial speech. Some English words may not be the participant's language. Getting written consent may be inappropriate in some cases, so oral consent needs to be obtained from reading out the consent form. A third party who speaks the participant's language is necessary to witness and verify the participant has understood. Empirical evidence indicates that culturally adopted interventions are effective in improving health and mental health outcomes. All right, so that brings us to the end of chapter 6.